Hello again. Let's consider this other problem, quite different from the first one we solved on Newton's law of dynamic viscosity. The question says a plate has an area of 1 millimeter square as it slides down an inclined plane having an angle of inclination 45 degrees to the horizontal with a velocity of 0.5 meter per second. The thickness of the oil film between the plate and the plane is 1 millimeter. Question says, find the viscosity of the fluid if the weight of the plate is 70.72 newtons. Okay, so you might want to actually pause and actually grasp this question because it says a plate has an area of 1 millimeter square as it slides down an inclined plane. So which means it is not like the usual question we solved where we have the both plates parallel to one another. In this case, you're having the plate sliding down an inclined plane. So let's get the picture down. Okay, so we have this inclined plane and we have a plate which slides down this plane. Okay, we have a plate which slides down this plane. All right, and of course, the angle of inclination was given as 45 degrees to the horizontal. So we have this angle here, 45 degrees. So between this plate and this plane, we have oil. Of course, between the plane and the plate, we have oil. And the weight of the plate was given as 70.72. And we all know this is the plate. Take note. This is the plate. And the weight of the plate was given as 70.72 newtons. And we all know that the weight of every plate acts vertically downward. So we have the weight of this plate. W is simply equal to 70.72 newtons. Now, the plate is actually sliding down an inclined plane with a velocity. So, which means the motion of this plate is down the plane, and the velocity down the plane is given as u equal to 0.5 meters per second. So, the velocity of the plate as it slides down the plane is simply 0.5 meters per second. Okay. I think that's all given to us. The area of the plate was given as 1 millimeter squared. So area A equals 1 millimeter squared. So take note, of course, you have to convert this to meters. And converting millimeter to meter is simply by multiplying by 10 to the power of minus 6. So this is simply 1 by 10 to the power of minus 6 in meter squared. So that's the area of the plate. I think that's all the information given to us. So we have to plot these diagrams first before you can be able to solve. So all we need to do now is the motion of this plane is inclined and not purely vertical or purely horizontal. So which means we need to resolve or find this weight in the direction of motion, because we can't use the weight component 70.72 newton because it's purely vertical. Meanwhile, the motion of the block itself or the plate on top of the plane is actually what's inclined. So all we need to do is we draw an imaginary line. Of course, we recall in friction, whenever two surfaces come in contact, there's always a normal reaction. But in this case, this plate is not coming in contact with this surface. Therefore, we just draw an imaginary line. Okay, we make an imaginary line, and I always say the angle between this imaginary line or this inclined line and any vertical line is simply the angle of inclination. So the angle here is something as 45 degrees. So we have this angle to be 45 degrees. So this becomes the vertically inclined component. Okay, and of course, if we draw this down here, we are going to have the motion of this block or the plate horizontally inclined. So simply call this okay, wx. Call this wx, call this wy. So weight inclined in the vertical axis. All right, so we need to now resolve this weight to be what? Inclined in the horizontal axis. So resolving the weight to be inclined in horizontal axis. Now take note, we don't resolve this weight to be inclined vertically because motion on the plane is not vertical. Motion is down the plane. So we only need what? Inclined down the plane. That's all we need. So we need to resolve this weight now down the plane. And I always say to resolve a force to any component, hold the tip of the arrow of the force, pull it to meet the component line. If it passes through the given angle, multiply by cosine of the angle it passes through. But if it doesn't pass through the angle on the quadrant, you simply multiply by sine of the angle. I have 45 degrees here, so which means if I'm resolving this force, I have to pull this force to meet, this is now the inclined component in the x-axis. Pulling this force to meet this component here, it didn't pass through 45 degrees, so I will simply multiply by, this becomes 70.72, that's the weight, multiplied by sine of the angle it didn't pass through, it becomes times sine 45. But then, of course, since here is 45, it also means that this angle left here is also what? 45. So you might also wish to multiply 70.72 by cosine of this angle, since it passed through 45 to get to this component as well. So it can also be 70.72 times cos 45. So of course, for two angles to be complementary, the sine of one is always equal to the cos of the other. And of course, complementary angles are angles that add up to 90. So 45 plus 45 will actually give us 90. So it means sine 45 is the same thing as cos 45. So it becomes the weight component in the direction of motion. That's 70.72 sine 45. Therefore, weight in the direction of motion becomes 70.72 sine 45. So that simply gives us 50 Newton. So this becomes the weight in the direction of motion. So it is this particular weight now that we are going to use throughout our analysis. Okay, that's the first thing to do. Next, you recall from Newton's law. Okay, recall that shear stress is actually mu du all over dy. Okay, so all we need to do is to find du dy, find shear stress, and make viscosity subject of the formula. That's all we need to do. But not forgetting, shear stress itself is actually force all over what? Area. The force in this case is the weight in the direction of motion. So this is now equal to the weight in direction of motion is 50 newtons. We simply have 50 all over area of the plate was given as 1 by 10 to the power of minus 6. So simply 1 by 10 to the power of minus 6. So this implies now that the shear stress is now equal to 50 by 10 to the power of 6 newtons per meter square. So this gives us the value of the shear stress. Keep it aside. All right, so next is to find the change in velocity, which is du. Of course, initial speed was not given, so simply take it as 0. The initial speed, you can call this u2 if you wish, or you can simply leave it as u. Okay, initial speed u naught is not given us, so take it as 0. Final speed u was given. Final speed u was simply given as 0.5 meters per second. All right, so we'll compute the change in speed or change in velocity, which is du, and that's simply u minus u naught, which is actually 0.5 minus 0. So this actually implies that the change in speed, du, remains 0.5 meters per second. So we have this. Next is to find the thickness. Of course, thickness of plate was given to us in the question. The thickness of the plate was given as 1 millimeter. Okay, if the thickness of the oil film between the plate and the plane is 1 millimeter, so this thickness was given from here to this point. Okay, this thickness was given as 1 millimeter. So we simply convert that. The y was given, thickness dy was given as 1 millimeter, which is actually 1 by 10 to the power of minus 3 in meters. Okay, therefore we cannot find du all over dy, and that's equal to du remains 0.5, all over dy remains 1 by 10 to the power of minus 3, and this is actually equal to 5 by 10 to the power of 2 per seconds. All right, so we have 5 by 10 to the power of 2 per seconds. That gives us the value of du all over dy. Okay. All right, so having this now, From shear stress equals mu du dy, we can actually make mu subject to the formula. From here, this simply means that dynamic viscosity mu is simply the ratio of shear stress all over du all over dy. So we simply have this. This gives us dynamic viscosity. So this is equal to shear stress value gave us the shear stress value gave us 50 by 10 to the power of 6. So we simply have 50 by 10 to the power of 6 divides by the u dy give us 5 by 10 to the power of, okay, minus 5 by 10 to the power of 2. We have 5 by 10 to the power of 2. And of course, this implies that mu is now equal to 1 by 10 to the power of 5 Newton seconds per meter squared. So this becomes the answer for the value of the dynamic viscosity, 1 by 10 to the power of 5 Newton seconds per meter square. All right, guys, so that's it for that question. I will see you in the next video with more questions on Newton's law of dynamic viscosity. Please, if you're new to the channel, please do well to click the subscribe button and of course share the channel to your friends to keep getting updates when content of fluid mechanics keeps dropping. I will see you in the next video. Thanks and cheers.